As we know, ionic compounds form from metals and non-metals. And as we talked about in chapter 4, metals form cations, non-metals form anions. Now remember, not everything forms ions, but if they do, metals form cations, non-metals form anions. And the aim of the game when you are writing a formula of an ionic compound is to have a charge of 0. So the size of the positive charge must equal the size of the negative charge so that they cancel each other out. You want your net charge to be 0. So let's look at some examples. Say we need to write the formula that forms between sodium and chloride. Sodium is in group 1A, so if you remember your little trick, elements in group 1A form 1 plus ions. Chlorine is in group 7A, so it forms 1 minus ions. And so we need to find enough sodiums and chlorines to cancel the charges. So because it's 1 plus and 1 minus, that one's super easy. We just need 1 sodium to balance out 1 chloride, so the formula is NaCl. Let's look at magnesium and oxygen. Magnesium is in group 2A, so it forms a 2 plus ion. And oxygen is in 6A, so it forms a 2 minus ion. And so we can easily cancel the charges between magnesium and oxygen, giving us MgO. Just 1 magnesium balances 1 oxygen. Now remember, the aim of the game is to balance the charges, but we also need the lowest whole number ratio of elements in the compound. Okay, so we could balance this with 2 magnesiums and 2 oxygens, or 10 magnesiums and 10 oxygens, but we want our subscripts to be the lowest whole number ratio, and in this case that's the 1-to-1 ratio. Okay, how about calcium and fluorine? Calcium is in group 2A, so it has a 2 plus charge. Fluorine is in group 7A, so it has a 1 minus charge. So to make that balance, we're going to need 2 fluorines to balance 1 calcium, which gives us CaF2. Okay, how about rubidium and phosphorus? Okay, rubidium is in group 1A, so it forms a 1 plus ion. Phosphorus is in group 5A, so it forms a 3 minus ion. So to cancel those, what do we need to do? We're going to need more rubidiums, right? We need 3 rubidiums to cancel 1 phosphorus. Okay, 3 rubidiums, 1 phosphorus. If that's not clear to you, let's draw it out. 1, 2, 3 rubidiums would be 3 plus. 1 phosphorus is 3 minus, and so we can see that that cancels and would give us a net charge of 0. And remember, that's the aim of the game. In an ionic compound, the aim of the game is to get a charge of 0 for the compound. So the size of the positive charge must be equal to the size of the negative charge. Okay? Let's do one that's maybe not as clear. This is aluminum and oxygen. Aluminum is in group 3A, so it has a 3 plus charge. And oxygen is in group 6A, so it has a 2 minus charge. And it's sometimes not as obvious how to cancel a 3 and a 2. But remember, what you're effectively doing is you're finding the lowest common multiple of the charges. And so the lowest common multiple of 3 and 2 is 6. So you need enough aluminums to give you 6 plus and enough oxygens to give you 6 minus, which is going to be 2 aluminums and 3 oxygens, because 2 times 3 plus is 6 plus and 3 times 2 minus is 6 minus. Let's set that up over here. We've got 2 aluminums, 3 plus each, that's 6 plus. And we've got 1, 2, 3 oxygens, they're 2 minus each, so that's 6 minus. So we can see that 2 aluminums and 3 oxygens will cancel. Now an easy way to do that is called the crossover method. You take the superscript, the charge, and you cross it over and you make it be the subscript on the other element. So we end up with Al2O3. The crossover method works for any compound, ionic compound, but I don't love it because people tend to forget to cancel the subscripts when they do that. For example, they'll take this 2 on the magnesium and this 2 on the oxygen, and they end up with Mg2O2, which is not correct. Okay, so pay attention to that. Okay, so that's how we write formulas of ionic compounds. Remember, they form from a metal and a non-metal, and the aim of the game is to get a net charge of 0.